Okay, so this is going to be part 2 of chapter 2. So I'm going to draw two parallel lines and we're going to talk about them a little bit. So the way you denote parallel is by that notation. And then here is a transversal which cuts through both of them. Okay, the transversal in this case is a line. All right, so we have a couple of things going on. So I want to say that these are here and here are alternate interior. Okay? And this is also. So all the alternating interior are brown in color. Okay, let's go for some red. So then we have alternating exterior. Red, red. Exterior means outside the lines. Red, red. Okay, so these alternate and then the others alternate. So the reds are alternating interior. Then they have other relationships as well. Okay, so alternating interior. Now let's go to vertical. Okay, so vertical will be green. So this angle and this angle is vertical. This angle and this angle are vertical because they're across the park. This and this is vertical. This and this are vertical. Okay, so they're vertical angles. That's the green. Okay, vertical angles are equal. Okay, alternate interior angles are equal. And where's that brown that we had? And alternate, interior angles. Okay, I'm going to make a correction here. These are alternate exterior. I think I said exterior, and then for some unknown reason, I wrote interior. So these are alternate exterior because they are outside the lines. Okay, so if you think about, let's just do this. We'll pick a color that's light. Okay, in here, these are inside. So that's why it's interior. So the pink is interior. Inside or in between the two parallel lines. On the other side of that are the exterior angles. Okay, so then you have a whole nother setup that involves corresponding angles. Okay, I'm going to go to the next page to do that. So once again, let's do our lines. Here are our parallel lines. I indicate parallel by these marks. Here's your transversal. Okay, I want to talk about corresponding. So, corresponding, if I label these 1, 2, 3, 4, then I'm going to tell you that they correspond to 1, 2, 3, 4. So match up the numbers to get your corresponding angles. Okay, if you think about taking these 4 and picking them up and putting it down here, you'll see that those will line up. So that's corresponding angles, a whole nother thing. Okay, corresponding angles are equal to one another. So angle 1 equals angle 1 down below, 2 equals 2, 3 equals 3, 4 equals 4. Okay, another page on parallel lines. So parallel lines, let's talk about things that aren't equal. So how about if we draw our lines? Okay, there are parallel lines indicated by these marks. Here's your transversal. Okay, so I'm going to change color. And I'm going to say, we're going to number this number 1 and number 2. So these two are same side interior. Okay, same side interior will sum to 180 degrees. They will not be equal. And this is the first set that we've not had them be equal. Okay, so that's one thing we want to talk about. Let's go to another slide. Okay, so here's our parallel lines, transversal. Okay, so now we're going to change color, and we'll say 1 and 2. Okay, so 1 and 2 are same side, so you can probably guess it, exterior, and guess what? Those angles sum to 180. Okay, so we've got a couple of more things to do with these. Okay, here's parallel lines again. Here's our transversal. And we're going to talk about supplementary angles. So if you have two angles on a line, so let's say this, so we'll have to change color. Okay, if you have angle 1 and angle 2, these are on a line. So they are supplementary. And supplementary angles sum to 180. Okay, so then we'll do another pair that are supplementary. How about 3 and 4? They'll sum to 180. How about 5 and 6? How about 7 and 8? Okay, they were all supplementary. So you can establish all kinds of relationships with the angles of parallel lines cut by a transversal. Okay, so that should help, but you definitely want to do that worksheet and check your answers because I posted the key as well. Okay, that takes us to the angle sum theorem slide. So let's put that up next. Okay, we did hit upon this already. So the triangle sum theorem tells me that the three angles of a triangle have to always sum to 180. So that means if I give you two of the angles, you can just do subtraction and get the third. So for example, if you're going to try to find this x, I see I have 65 plus 57, which is 122. So then I would say, okay, they have to all sum to 180. So 180 minus 122 looks like 58 degrees will be what x equals. Okay, what about this x? If I sum 130 plus 20, that's 150. And 180 minus 150, that's going to make that 30 degrees. So this angle, this triangle, is an acute triangle in terms of classification by angles. This, because you have this big angle here, that's an obtuse. Oh, look, this little box is 90 degrees. That's a right triangle. So in order to get your x here, if this is 90, then 40 plus this side must be another 90, so that you can have 90 plus 90, 180. So that's going to be 50 degrees. Okay, so you want to be very, very comfortable completing the angles in a triangle, given sufficient information to do so. Okay, let's go on to the next. Okay, there's a lot to cover with quadrilaterals, and on Joule for chapter 2, day 2, I did put a understanding quadrilaterals exercise that I want to make sure that you do, and I've included the answer key with that. So please look at that carefully. Okay, here are some words you should become very familiar with, and there's 7 types of quadrilaterals. Parallelogram, which means you have two parallel sides, 2 sets of parallel sides. Isosceles trapezoid. That means that these, go back to this. That means that these sides, do that one more time. Okay, these sides are equal because this isosceles trapezoid has 2 sets of parallel sides and 2 that are not parallel. Okay, rectangle has two sets of parallel lines just like the parallelogram, only the corners are all right angles. Square, you have 4 congruent sides and 4 congruent angles. Okay, trapezoid again, you've got 2 sets that are parallel and 2 that are not. Okay, rhombus is like taking a square and stretching it. So all 4 of these are the same length, but you do not have right angles in the corner. And a kite has these 2 that are the same length, these 2 that are the same length, and none are parallel. Okay, so those characteristics are important. In terms of the angles inside, we know that the angles inside have to sum to 360. How do I know that? Well, don't forget we have that n minus 2 times 180. In this case, the n is 4. 4 minus 2 times 180 does indeed give me 360, so that checks. Okay, so here are some of the characteristics of quadrilaterals expressed very nicely and very concisely in this table. So the sheet that I put up there for you to look at on Joule for Chapter 2 asks you questions about this relationship. Okay, so you want to go through those questions and then you can check on the next page for the answers. Make sure that you understand that. Okay, the next page presents these properties in another way without checkboxes but with words instead. So let's do that next. Okay, so here's that next slide. It's called Quadrilateral Properties. And you can see they show you the type of quadrilateral. They give you the picture and they give you the properties. So you probably want to illustrate that on those sketches just so it's clear in your mind what these properties are and how they're similar and how they are different from one another. Okay, we're going to go on to area in 2.4 next. Okay, so when we speak about area of figures, we have some common figures here. So a rectangle is just base times height, and that's because the height will be perpendicular since it's a rectangle. The area of a parallelogram is also base times height, but you have to figure out the height by dropping a perpendicular here. Okay, quite frequently, they'll only give you the lengths of the outside, and then there's a way to figure out the height of the perpendicular. But if they give you 3 numbers, you definitely want to know that you need height, which has to be perpendicular, times the base, which is the bottom of the shape. Okay, the area of a triangle is 1/2 base times height. So again, the formulas are very similar. A triangle is actually, when you think about it, look at a rectangle and divide it in half. So you see how that's really half of a rectangle? So that's why the formula is 1/2 base times perpendicular height. So again, you need to get the perpendicular height. It's not always given right away, but that's what you need to determine your area. Okay, so here you're going to find the area of a general figure, and to do that, you're going to break it up. So method 1, you could take this, you can take this shape and break it up by drawing a perpendicular line right there, and then that's method 1. Or instead, you could add to this shape by adding that, and then subtracting away the piece that you don't really have. So check out these methods. They're kind of fun to work with and be able to find the area of an irregularly shaped figure. Okay, in this slide they talk about circles. So there's a lot of vocab here. Circumference is kind of like the perimeter. It's the outside of the circle. The radius is half of the diameter, and it starts at the center, which is this dot right here in the middle. Okay, so the circumference, to find its length, it's 2 pi r. Okay, so usually you would just use your pi key, or you would leave pi in your answer. Okay, the area of the circle, which is everything inside the circle, is pi r squared. Those are 2 equations that you should know. Okay, there's a math is fun link here. I would absolutely suggest that you link in there and do some of that practice. Okay, there's more vocab words here. So here is the center of the circle right there. If you draw two radii and connect them, then this angle in the middle is called alpha in this example, and that's your central angle. Central angles come from the middle. Okay, the arc that your radii hit is called the intercepted arc. Okay, then if you take the same radial endpoints of A and B and instead connect out to the opposite end of the circle, that's called an inscribed angle. So here's another second vocab word. Central angle and inscribed angles. Central angles and inscribed angles have relationships. So for example, if the central angle, let's just say it is 60 degrees, then the inscribed angle would be half of it, 30 degrees. And that's what this formula tells you. Okay, so it says, note, inscribed angle has its vertex, so that's the V part right there, has its vertex, let me just read that, on the circle, while a central angle, okay, so here's the vertex of the inscribed angle, a central angle has its vertex in the center of the circle. Okay, so understand how to recognize both inscribed angles and central angles. And again, this math is fun. It's a good way to do that. Okay, 3 more slides and this is history. Okay, couple of more things about circles. So the arc length. So this arc length right here is called S. Okay, so the arc length S of a circle with a radius of R and a central angle of theta is given by this equation. So the arc length equals the radius times theta. One caveat. This has to be in radians. How do you convert to radians? This is your conversion factor. So read about this a little bit so that if I ask you for arc length, you're going to have pi in your answer. All right? So for example, what if I said that theta, if theta equals 90 degrees, 90 degrees times pi over 180 gives me pi over 2. So pi over 2 is the radian measurement. So if I said that this particular circle has a theta of 90 and an r of 8, say, then S, the arc length, has to equal r times theta. So r is going to be 8. Theta is pi over 2 in radians. That's going to be an arc length of 4 pi because the 2 goes into 8 4 times. Okay, so understand that, think about that, and we'll move on to another piece of information about circles. Okay, so this is another fun thing about circles. If you cross lines inside circles, there's a certain kind of relationship that shows up. So if you want to talk about segment lengths, or these are also called arc lengths, okay? If you know the arc lengths, then you can figure out this angle right here. Okay, so for example, so I'm going to draw this again. I'm going to cross some lines right there. I want to find my x. If I tell you that this is 60 degrees, it has an arc length of 60 degrees, and this has an arc length of, let's say, 40 degrees, then to figure out what the angle x is, I'm going to add those arc lengths. 60 plus 40 is 100, and divide by 2, and I figure out that my angle is 50 degrees. Okay, you can keep everything in degrees here. Okay, so that's dealing with angles. What about the chord lengths? Is there a relationship? Well, yes, there is. So when you have chords that cross, this is the relationship. AB, that product, is going to equal the product of CD. So that means if I give you arc lengths and I give you maybe a variable with it, you can solve for the missing term. So what if I said this was 2, this was 4, this was 10, and this was x? Okay? So what do I know looking at the drawing above? X times 4, so 4x equals 10 times 2 equals 20. What is x going to be? Divide by 4, divide by 4. X will be equal to 5. Okay? So those are two things about line segments. They give you information on angles, and they give you information on chord lengths. So a chord is when you connect from one side of the circle to the other side, and you do not go through the radius. Go through the center of the circle. If your chord goes through the center of the circle, it is a special chord. It is a chord called a diameter. Okay, these chords are not diameters because they do not pass through the center of the circle, which is represented by that block dot right there. Okay, almost done. We've got one more slide, and it's just going to be a discussion slide. Okay, I don't believe we're going to do a lot with this material, but I just wanted you to have the ability to see it all in one place. So it's telling you how to calculate other kinds of areas. Okay, so you have surface area, you have lateral curve surface area. Everything's all here in one place. If I'm going to use this at any level, I will give you the formulas. If I don't give you the formulas, I will tell you ahead of time what you need to know. But for right now, I would just view this as for your information and leave it at that. So that completes the second part of the video for the notes for Chapter 2.